Hello friends, I am Balaji Rao. Welcome to BR Max class. This is 5th class on Principle of Mathematical Induction. Till now we learned the definition of Principle of Mathematical Induction and we practiced 12 problems based on Principle of Mathematical Induction. In this class we will do another 2 problems. In these 2 problems, proving P of k plus 1 is little difficult. Have patience, watch this video till the end. Let's begin the class. You see here, I considered given statement as P of n. After considering given statement as P of n, to prove this by principle of mathematical induction, we prove 2 things. First, we prove P of 1 is true. Next, by assuming P of k is true, we will prove P of k plus 1 is true. Now, first I'll prove P of 1 is true. To prove P of 1 is true, in place of n, we will take 1 because we are trying to prove P of 1 is true. In the given statement, in left hand side, you take this nth term. In this nth term, wherever n is there you put 1. Then what you will get? 2 into 1, 2, 2 minus 1, 2 minus 1 into 2 into 1, 2, 2 plus 1, 3. So here 1 into 3, that equal to 3. So LHS is 3. Right hand side part, n into 4n square plus 6n minus 1 divided by 3. In this, wherever n is there you write 1. So 1 into 4 plus 6 minus 1 divided by 3. 6 plus 4 is 10. 10 minus 1 is 9. 9 divided by 3 is 3. So LHS is 3. RHS is also 3. As LHS is same as RHS, we can say that this statement is true for n equal to 1. That means P of 1 is true. Now we proved first part in this problem. Now second part. What is second part? You assume P of k is true. By assuming P of k is true, you need to prove P of k plus 1 is true. You observe here, I assumed P of k is true and I written what is P of k. How you will get this P of k? In this P of n, in this statement, wherever n is there if you write k, then you will get P of k. You observe here, in this statement, wherever n is there I written k, so I got P of k. In almost all the problems, after this step, we will add a term on both sides. How to get that term? You observe here, I consider kth term of P of k. In this, wherever k is there you write k plus 1. You see here, in this, wherever k is there, I written k plus 1. You do little bit of simplification. What you will get? This is 2k plus 2 minus 1. That is 2k plus 2 minus 1 is plus 1. Into, yes, 2k plus 2 plus 1, that is 2k plus 3. So I'll add 2k plus 1 into 2k plus 3 on both sides. You observe this is P of k plus 1. How you will get this? In this P of k, wherever k is there you write k plus 1, then you will get P of k plus 1. You will get this. What I did here, this RHS part, I simplified little bit. See, k plus 1 into, this part is there, no? 4 into k plus 1 whole square plus 6 into k plus 1 minus 1. If you expand and simplify further, then you will get 4k square plus 14k plus. What I am trying to say, it is important to keep in your mind what is P of k plus 1. Okay, now come back to the main thing. As you assumed this statement is true, for this, if you add a term on both sides, whatever you will get, that is also true. Now, the only thing what I want is, I'll simplify this right hand side part little bit and I am trying to get RHS of P of k plus 1. Take 3 LCM, then what you will get in the numerator? K into 4k square plus 6k minus 1 plus 3 into 2k plus 1 into 2k plus 3. Now, I do little bit simplification of this. We will see what you will get. Multiply with k. K into 4k square, that is 4k cube plus k into 6k, that is 6k square minus k plus Now you multiply these two terms and multiply with 3. 2k into 2k is 4k square. 4k square into 3, that is 12k square, plus 2k into 3 is 6k. 6k plus 2k is 8k. 8k into 3 is 24k, plus 1 into 3 is 3. 3 3s are 9. If I simplify further in the numerator, what I'll get? I'll get like this: 4k cube plus, see here, 6k square plus 12k square is 18k square, minus k plus 24k is plus 23k plus 9. Now I need to simplify this. I need to split this further into quadratic factors, linear factors. So to do this problem further, I'll use synthetic division. What is synthetic division? You draw a shape like this and you take k cube coefficient. K cube coefficient is 4. Next k square coefficient, that is 18. Next k coefficient, that is 23. Next constant, that is 9. And you put 0 here, always 0 will be there. You observe this p of k plus 1. As I need k plus 1 here, what I'll do? I'll put minus 1. Now 4 plus 0 is 4. Minus 1 into 4 is minus 4. 18 minus 4 is 14. Minus 1 into 14 is minus 14. 23 minus 14 is 9. Minus 1 into 9 is minus 9. Minus 9 plus 9 will get cancelled. You will get 0. What we can write from this? This 4k cube plus 18k square plus 23k plus 9 can be written as k plus 1. Here minus 1 is there, means we will take plus 1. Here if plus 1 is there, then we will write minus 1. Now you look here, constant term, k square term. What it will be? 4k square plus 14k plus 9. So this 4k cube plus 18k square plus 23k plus 9 can be written like this. If you want, you multiply these two, you will get same thing only. So here in place of 4k cube plus 18k square plus 23k plus 9 can be written like this. Can be written as k plus 1 into 4k square plus 14k plus 9. And as usual, whole divided by 3. You observe this step. What we got? We got RHS of p of k plus 1. Look here. This is RHS of p of k plus 1. Let me write this left hand side part also. Now let's come to the main point. As you assumed p of k is true, after adding a term, whatever the statement you got, that is also true. This statement is true. After doing little bit of simplification here, what you got, that is also true. This is true. What is this? This is p of k plus 1. Therefore, I'll write p of k plus 1 is true. See what we did. First, we proved p of 1 is true. Next, by assuming p of k is true, we proved that p of k plus 1 is true. Therefore, by principle of mathematical induction, we can say that p of n is true. Hence, we proved given statement by using principle of mathematical induction. Now, we'll try to do one more problem of same type. You see this statement. We need to prove this statement by using principle of mathematical induction. To prove this statement by using principle of mathematical induction, first we will take given statement as p of n. You look here, the given statement I considered as p of n. Now to prove this statement by using principle of mathematical induction, we need to prove two things. First, we will prove p of 1 is true. Next, by assuming p of k is true, we will prove p of k plus 1 is true. First part, I'll prove that p of 1 is true. How we prove p of 1 is true? See, in place of n, I'll take 1 because I am trying to prove p of 1 is true. How to prove p of 1 is true? First, in the given statement, left hand side, you take the nth term. You take the nth term. In this nth term, wherever n is there you write 1. Then what you will get? 1 divided by 1 into 1 plus 1, 2 into 1 plus 2, 3. So that is 1 by 6. Now, in the given statement, you consider right hand side part. N into n plus 3 divided by 4 into n plus 1 into n plus 2. In this, wherever n is there you write 1. Then what you will get? 1 into 1 plus 3 is 4 divided by 4 into 1 plus 1, 2 into 1 plus 2, 3. You see here, this 4 will get cancelled. Then what you will get? 1 divided by 2 into 3 is 6. So LHS is 1 by 6. RHS is also 1 by 6. So LHS equal to RHS. So we can say that P of 1 is true. So first part of this problem completed. Now second part. What is second part? By assuming P of k is true, we need to prove P of k plus 1 is true. Now first I'll assume P of k is true and I'll write what is P of k. Now you see here, I assumed P of k is true and I written what is P of k. How you will get P of k? In this P of n, wherever n is there you write k, then you will get P of k. After this step, in almost all the problems, we will add a term on both sides. How to get that term? You look here. In this kth term of P of k, wherever k is there you write k plus 1. What term to add on both sides? You see, in place of k, in this term, in place of k, you write k plus 1. See here, k plus 1 plus 1, that is k plus 2. K plus 1 plus 2, that is k plus 3. So I am adding this term to this P of k on both sides. For this P of k, I added this term on both sides. Okay. Now, what is our intention? We are trying to prove P of k plus 1 is true. It is important to keep in your mind what is P of k plus 1. What is P of k plus 1? In this statement, in place of k, if you write k plus 1, then you will get P of k plus 1. You see here, in this, in place of k, if you write k plus 1, you will get this. So what I am trying now, after simplifying this right hand side part, I am trying to get RHS of P of k plus 1, this one. Okay. Now, you start simplifying this. You observe this right hand side part. In the denominator, k plus 1, k plus 2 is there. Here also, in the denominator, k plus 1, k plus 2 is there. So what you do, you take k plus 1, k plus 2 common in the denominator. Then you will get like this. That equal to 1 divided by k plus 1 into k plus 2. You just start simplifying this. You start simplifying. What you will get here? What is LCM? LCM is 4 into k plus 3. Okay. Now what you will get here? K into k plus 3 into k plus 3. K plus 3 whole square plus 4. Okay. That equal to 1 divided by k plus 1 into k plus 2. You simplify this numerator part. You expand k plus 3 whole square and multiply with k. K square into k, that is k cube, plus 3 square is 9. 9 into k, 9k, plus 6k into k, that is 6k square, plus 4 whole divided by 4 into k plus 3, 1 divided by k plus 1 into k plus 2. Okay. You observe this one. This is a cubic equation. We need to reduce this cubic equation further into quadratic factors and linear factors. For that, as we discussed in last problem, we use synthetic division. In synthetic division, you write a shape like this and you take k cube coefficient, that is 1. You take k square coefficient, that is 6. You take k coefficient, that is 9. And you take constant, that is 4. And now always you put 0 here. Now you observe, this is the term we are trying to get. Here, as k plus 1 is there here, you put minus 1 here. As k plus 1 is needed, you put minus 1 here. If we need k minus 1, then we will put plus 1 here. Now start simplifying. 1 plus 0, 1. Minus 1 into 1, minus 1. 6 minus 1, 5. Minus 1 into 5, minus 5. 9 minus 5, 4. Minus 1 into 4, minus 4. So 4 minus 4 is 0. Actually, in last problem, we stopped at this point only. But we can continue this further. As you need here k plus 4 also, what I'll do, I'll write minus 4 here. Now, as usual, 0 will be there here. 1 plus 0, 1. Minus 4 into 1, that is minus 4. 5 minus 4, that is 1. Minus 4 into 1, minus 4. 4 minus 4, 0. What point we can learn from this? You see here, this k cube plus 6k square plus 9k plus 4 can be written as k plus 1. Here minus 1 is there, na? That's why k plus 1 into k plus 4 into constant term, kth term. That means k plus 1. So if you multiply all these three terms, again you will get this only. If you want, you can try. So in place of k cube plus 6k square plus 9k plus 4, what I will write? I can write k plus 1 into k plus 4 into k plus 1 whole divided by 4 into k plus. Now you observe this k plus 1 will get cancelled. What is there in the, what is remaining here? You observe what is remaining here. K plus 4 into k plus 1 into 4 into k plus 2 into k plus 3. Oh, you observe this is RHS of P of k plus 1. Now I'll write this left hand side part also. Okay, you see here what happened finally. As you assumed P of k is true, after adding a term on both sides to this, whatever you will get, that is also true. I just did little bit of simplification in right hand side part. Now whatever you got, this is true. What is this? This is P of k plus 1. That means P of k plus 1 is true. So what happened? In first case, we proved that P of 1 is true. In second case, by assuming P of k is true, we proved P of k plus 1 is true. Therefore, by principle of mathematical induction, we can say that P of n is true. Hence, we proved given statement by using principle of mathematical induction.